The agenda for today's presentation, as I was saying, is divided in two sessions, the webinar itself. In the first part, there is a 20-minute presentation. And in the second part, there is a live demonstration with Panos. In the presentation, myself, I will cover three sections. First, an introduction to services, what they are, the different type of services, and what are the monitoring options available to monitor these services. In the second part, we will introduce distributed network monitoring, as some may be already familiar and some not. And we'll see how distributed network monitoring is applicable to enterprises that have many locations or a large wide area network. We'll see also how to deploy such a solution and what NetBees is about. In the last part of the presentation, we'll offer some insights on how to monitor DNS and cloud services and show what are the limits of existing centralized network monitoring solution and what are the advantages of distributed network monitoring. Then Panos will show a real life demonstration of NetBees and how to create targets to achieve these goals. Little introduction about the presenters. Myself, I'm the co-founder and CEO of NetBees. My name is Stefano Gridelli, and I was a network engineer for several years. And in my past career, I built and designed several large networks based on MPLS. So really routing and switching was my bread and butter. I'm also holder of a certification from Cisco and from Alcatel-Lucent. The co-host is Panos Vouzis, co-founder and a COO, as well as the main developer on the agent of NetBees. Panos has a background in computer engineering, and he's a designer of embedded and distributed systems. So let's start with the presentation. Let's introduce services. So what is a service? A service is an IT service is based on the use of information technology to support the customer business process. And IT services, at the end, a combination of people, processes, and technology are defined in a service level agreement. So as you can read from the ITIL definition, it's really a mixed solution of different components. And for us, IT professionals that have to provide service to our end users, whether they're our customers or employees of our company, it's really difficult sometimes to understand what components a service. So it's really important to know what defines a service and what defines the services that we provide to our end users. Another compelling definition from Merriam-Webster is that a service contributes to the welfare of others. And this is really compelling because you can really understand that when we provide a service to someone, we are really contributing to his welfare. So we're really adding value to his life, bottom line, or his activities. So for this reason, it's really important that we provide services at the best possible manner that we can, the best service level agreements, and the best satisfactory to our end user. And to do so, it's really important that for any service that our end users have to access, we understand what is under our control when there is a failure or a performance degradation issue, and what is outside our control. So in this slide, I want to show how some services may be under our full control, while others are outside our control. So in that case, it's really important because whether we fix it or we escalate the problem to a third party or another group within the IT organization, it's important that we get to this point as soon as possible. And here we listed some services that can be completely in-house or outsourced. Of course, these categories are really different from company to company, as each company is implementing a different IT strategy. So what are the network monitoring options that we have available to monitor a service? Well, first of all, you might agree with me that the market is full of different network monitoring options. So it is important when going to shop for a solution to understand what each specific solution is doing. And we classified all these solutions in 3 categories. The traditional and the most known one is the one based on SNMP data. These tools are also called network node managers because they monitor at device level the components of a network infrastructure. These tools are great to provide up-down status about routers, switches, or access points, but they're not really effective to monitor services as experienced by the end users. They don't perform transactions, and on top of that, they monitor from one location where the SNMP collector or server is installed, typically the data center. And as we all know, users are all over the place nowadays. The second category is based on flow data. And here we find taps, span ports, or any other type of device or protocol like NetFlow that give us passive data about existing connection between users and applications. So these are really good tools to monitor reactively an issue between a client and a server, for example, but they're not really great to monitor in a large wide area network, hundreds of users accessing every day, every second, cloud or internal services. Because these solutions are mostly installed in central point of the network, taps are really expensive, they hardly scale for this reason, and second, they to generate proactive alerts, performance alerts based on baseline is really difficult because the amount of storage required for such analysis is really large. So this is where network monitoring solutions based on active data are really designed to monitor services effectively. First of all, because they perform 24/7 transactions at the network and at application layer with cloud services. Second, because they're really scalable. They can be installed in dozens or hundreds or different network locations. And they don't require really a lot of space to generate a baseline, thus proactive performance degradation alerts. So let's introduce distributed network monitoring. As you're familiar, multi-site enterprises with a medium or large size network has many users spread in different locations, offices, branches. So this is like very typical in higher education, healthcare, financial services, or oil and gas, for example. But it's really applicable to a vast array of industries. So going back to the services, it is our responsibility as IT professionals that support a number of users around this network. It's really important to understand what are the services or the component of the service that are under our control and which one are not. So when a problem happens to our users and they cannot access this or that service, we have to quickly identify if it's something that we should fix or escalate with another group or third-party service provider. And this is where distributed network monitoring comes to help. By installing one monitoring agent or network sensor at each site, we can in real time and continuously monitor those services that our users have to access every day, every second. And they do this very well because they're small devices, plug and play, and they can tell us if a problem is only located to one or multiple locations, and if it's on the network or on the application layer. So that means the escalation is much quicker because of information about the scale and the layer of the problem. And this is what NetBees is about. NetBees is a distributed network monitoring solution. We have different type of agents for different network environment. As networks are always more from legacy to hybrid, they can be on-prem or on the cloud. And we have gigabit Ethernet or fast Ethernet hardware agents for small offices. We have wireless agents or external agents if you want to monitor from the internet user perspective, or virtual agent for data center or virtual environments. NetBees is able to perform at scale active end-to-end tests from all these agents and collect performance measurement in real time. The data that we review on the dashboard can be also saved on the central server and is processed and analyzed for proactive performance alerts. The benefit of NetBees as a distributed network monitoring solution are four. First of all, you can quickly escalate the tickets. Even before they hit your help desk, you can understand if a problem is from one or multiple locations and if it's on the network or application layer. Second, they reduce troubleshooting time because the engineer already has all the data available on the dashboard to provide the root cause analysis. Second, they're used to validate configuration changes because when you deal with a large wide area network or with complex services or systems, as an engineer applying a change, it's difficult to validate that there was not impact after the change to the end users in a dozen or hundreds of different locations. But by relying on distributed monitoring agents that do this validation continuously for you from all the sites, it's really quick to immediately catch errors and fix the problem. And fourth, because you can store a lot of amount of data from an historical point of view, you don't lose memory about the performance of your network. You can detect performance degradation on the long term and plan where or what area of your network or infrastructure should be upgraded during budgeting season. So how can we use a distributed network monitoring solution like NetBees to successfully monitor services like a DNS or a generic cloud service and provide the best service to our end users or customers? If we look at the scenario of an enterprise with many locations, and at each site of this remote location, we have a user trying to access a cloud application, and this is always more the trend that is happening right now. So with a traditional SMP-based network monitoring solution that has a server only at the data center, we can only obtain information and performance from one point of view, which is the data center. This solution, unfortunately, don't give us any feedback about service performance as experienced by a remote user in San Francisco or New York City. As you can imagine, by installing one agent at each of our remote office, we can gain a full network visibility and be able to support our end users, whether they use internal applications or cloud services, likewise. Or let's take an example of a DNS. Traditionally, remote branch offices or in legacy environment, always more they were connected through an MPLS line, private connection back to our data center. And the DNS used by a remote workstation, the actual corporate server present in our data center. So in those legacy environments or with that design, an SNMP was just fine to monitor DNS service availability and performance. However, nowadays, always more enterprises were seeing that they're relying on commodity internet that is cheaper and faster and getting reliable, almost enterprise grade. They're relying on this new connection to provide connectivity to remote offices. And perhaps then they build on top of that a VPN tunnel back to the corporate center for private connection. So what does that mean is that remote users are using the local ISP DNS server and not anymore our centralized DNS server. Also, what does that mean is that a centralized SNMP-based tool cannot detect remote performance issues. So I'm sure you follow me that by installing a NetBeans monitoring agent at a remote site, you now can gain the visibility that you lost when you decided to use commodity internet for remote locations, because you can instruct your remote agents to continuously run tests on DNS servers. With that, if there is a performance issue caused by a DNS server, by an internet service provider that your organization is using for a remote office, you can quickly detect that and be alerted. I hope that this first part of the webinar was beneficial to understand a little more what a service is, what distributed network monitoring is, and how it can help to monitor services such as cloud or DNS service. I will give it now to Panos, who will run a live demonstration of NetBeans. So yours, Panos.
Thank you, Stefano. Before I get started, I want to encourage you to ask any questions you may have either over the chat window on your go-to client or by email at info@netbeans.net. So during the demo, we'll go through a quick overview of the dashboard through a use case that shows how you can troubleshoot a network failure application. And then I'm going to give 2 examples of how you can start monitoring tests to monitor applications, as like HTTP applications, and also DNS services. Now, just to show you a little bit more in detail how you would monitor, for example, an HTTP application, on this slide, I present you 4 tests. Obviously, with ping and traceroute, you can monitor the network layer and application. And let's not forget that these days, the network is part of the application stack. With DNS, you can monitor the name resolution, obviously, make sure that all your users from different locations that may be using different name servers can access applications on their browsers. And with HTTP, you can monitor the application itself. And of course, you want to monitor, you want to get notified when something goes wrong. So you can have 2 types of alerts, right? You can have alerts that tell you if an application, of course, fails, but you can also have performance alerts, which give you 2 different perspectives. One can be an SLA type of alert. So, for example, here, you can put a fixed threshold on the latency of 200 milliseconds, and now get notified when this SLA is not met. You can also have historical type of alerts where you collect data, you create baselines for its location in your network, because of course different branch offices, retail stores may have different performance. Then when a performance at a specific location goes out of whack, then you can also get notified, because that means that there is a degradation in user experience. So here, for example, we give recommendations how an SLA type of alert would look like: 200 milliseconds for latency, 80 milliseconds for DNS, and 1 second for the HTTP response. And then baselines, again, can be tuned according to your, how aggressive you're going to be in terms of the user experience and get notified when something goes wrong. So the same type of idea applies when you want to monitor a service like DNS. So with DNS, you can run a ping test and traceroute test of your DNS servers that you have around your network, either public or private. And of course, you can also test the DNS service by running the resolution test to make sure that the server itself works as expected. Now I'm going to move on and go to our dashboard and show you how things look like here and how you can use it to set tests and troubleshoot networking application issues. Let me go full screen here to browser-based dashboard. And I'm going to start with the Ads tab. Okay, so this is the high-level bird's eye view of your network. Of course, you know, you can see here that a number of alerts open right now. This is a timeline of 1 hour, the past hour, and actually some alerts were just triggered. You can see here we have 2 ping alerts, 2 HTTP, and 1 traceroute alert open right now. However, this doesn't give us details about where these alerts are coming from. And to get that detail, we can move on to the next tab, which is the agent view. And so here we see now a couple of locations that have some kind of a problem, right? So these are 22 agents. And of course, on the same dashboard, we can have a combination of a mix of any type of agent. We see here we have Wi-Fi agents, fast Ethernet gigabit agents, and cloud agents to cover any environment you have in your network. And let's focus, of course, on the agent that has these open alerts. I click on it, and I know that this agent now is located in our Pittsburgh office, and I see that there are 2 alerts open. So we cannot access our website, we cannot ping our website, netbis.net from Pittsburgh. And of course, since we cannot access the website, we cannot also, you know, like run an HTTP test, right? Well, normally I know that our website would respond to ICMP, but in this case, something happened here, and we're not able to access it anymore, right? Of course, DNS works fine. The resolution is, you know, according to normal standards. And the other thing I notice here is that I have a performance alert on traceroute. So with red, you see failed test in the dashboard, and with yellow color, you see performance issues. And the way I defined performance alert was to get notified when my 15-minute average, which is in this case 30, okay, is greater than the watermark value of 15 hops. So I knew that normally I could access netbis.net from our Pittsburgh office in 15 hops, and I want to get notified when this gets violated, right? In this case, it's been violated since the 21st of this month. And let's give you a background here. The reason that we don't access netbis.net from Pittsburgh is because our ISP did some kind of a routing change of the background overnight, and of course, that's beyond control, right? So this is the type of alert and issue that Stefano covered, where you can get notified about an issue by measuring the user experience of that location. But in this case, unfortunately, standard is out for control, right? And of course, talk to our ISP and tell them about it, but there's not more we can do than that. Now, the next point I want to hit here is very important point, is to differentiate between a global and local problem, right? Is this a problem experienced by only one location or by all my users at all locations? And to do that, I'm going to move the target view, and I'm going to focus again on this target that's monitoring our website. And from here now, I can see that I have, of course, a couple of head alerts, but I also see a number of other locations that can access our website just fine. So that very quickly tells me that this issue is isolated in Pittsburgh, okay? And I should be looking at that specific location to see if something's wrong, right? As I said, the problem is with the ISP, but at least I know that I don't have to worry about other locations in my network. So again, this is the idea here, where you know how your users experience in a distributed fashion your applications and services. Great. Now, let's move on and show you how you can yourself create, for example, targets and monitor an application. In this case, we have a test app running on our cloud infrastructure. And I'm going to monitor this application by running a ping test, obviously, to cover the network layer every 5 seconds with 5 seconds interval. And I'm going to add a couple of alerts here. The first alert is an up-down alert. So if 5 consecutive tests fail, then these are the red alerts you see on the dashboard. And also I'm going to add a performance alert. In this case, is a baseline type of alert where I'm going to get notified when my 1 hour average of this round trip time to test.netbis.net is more than 3 times from one target. So what you can do is you can deploy dozens of agents around your network, let them collect results for a week, create baselines, and then get notified when something goes beyond your baselines by a certain multiplier. So ping test in place. I'm going to make sure I can resolve net.net, and I'm going to choose a specific server to test this. If I don't put the server here, this agent will try to resolve netbis.test to netbis.net with the name server was configured with from the local DHCP. I have this, of course, an HTTP test to monitor performance, and a trace route to monitor again routing. So every 2 minutes, this one. So I'm done with the types of tests. Now let's look now at what agents want to push this test to. Now let's see. I'm going to choose some US locations. I'm going to filter here. So this is in our Austin, Pittsburgh. This is New York. This is in Morgantown. So 3 agents. Then maybe a couple of international locations, Hague and Paris. I also want to add this cloud agent in order to make sure that this application is accessible from the external users outside my network. And I'm pretty much done here. So that's these 6 agents, a good mix of agents from different locations, and I'm going to add my email here to receive alerts when something goes wrong. So when there's an alert triggered, performance with failure, I'm going to receive an email and tell me which one, which test failed. So here it is, the test of target has been created, results will be coming in a couple of seconds. So here it is. So very easily here, as you can see, you have dozens or hundreds of agents in your network. You can, with a few clicks, maybe start the test from all your agents, right? If you want to make sure you have a very critical application running your data center, for example, and you want to make sure it runs, is accessible and good performance from all users in all your locations, you can just start a test of this type from all your locations. So this is a good example of how we want an application, the network layer, the DNS resolution service, and the application itself. The results are coming in here, as you can see. And now let's look, we have already a target here that is monitoring a service, DNS resolution service, and we have a number of tests here, right? So let's click on the first one, the ping test Google one. And from here now, we can see that what we are doing, we are pinging Google's name server. And actually, we're using, we're monitoring 2 different servers, right? So you see here that both agents are pickable from Paris and all other locations. Okay, as you can see, different performance obviously, right? You see from New York, it's 10 milliseconds, and from Paris, around 40 milliseconds on average. So we're making sure that we, from all those locations, can ping and access the name server. Then we are running a name resolution test. So we're trying to resolve google.com by using this server to make sure that everything, that the server itself works. And we also run a trace route test, again, for the same reason to test. We have to have a path analysis of what is the route from each location to each specific server. So I show you here how we can create targets and how we see the results here from different locations, so we can very easily identify where products are coming from, when they started, either intermittent, by having the historical, and so on and so forth. And I'm going to conclude the demo with a quick overview of our reporting view here. So from here now, we can create reports and compare locations in our network and see how, for example, this DNS server target I created, how different locations performed the last 7 days. So it shows the target, the time window. Now I'm going to see here how different locations compare to each other. So you see, obviously, this is the Paris agent that has the worst performance when it tries to ping 8888. It has the highest packet loss, okay? and the highest number of alerts created in the past 7 days. So here, for example, if you were to do an evaluation of your network and want to make improvements and wanted to focus, of course, on locations that suffer more than others, that's performance, you can make a knowledgeable decision on how to move forward with your planning. So all the data collected is available from the dashboard, and you can very easily have this high-level view and share it with your management to make the appropriate decisions.